Well, hello. In this lesson, we are going to learn about the measures of the center, right? Like a lot of what we learn in this section, you have seen before, like from a very young age, mean, median, mode, and probably not mid range as much, but a lot of it you have seen over the years that we're covering. The notation is definitely different that you may not have seen before. And doing it from a frequency distribution is definitely a little bit harder and different. But let's go over what is the measure of the center. So remember, the measure of the center is the middle, right? The average. So we hear that word average in this as well, right? The measure of the center. How do you find the average? Well, a lot of times people just assume that's the mean. But we also have the median and the mode, and they all in the mid range. They all find the average. Okay. So when we see the word mean, this in like Excel is average. So maybe it's been changed. Anyway, I think it's still as average, which is crazy to me. But a lot of times when people refer to like I averaged your grade or something, they refer to the mean. But you're in a stats class, so you should know that the median and the mode are also ways to find the center of your data. So how do I find the mean? I take all my datas, right? They're numbers, add them up and divide by however many I had. Okay. So you're going to add and divide. So that's how we find our mean. The properties of the mean are a big deal here. So, first of all, sample means drawn from the same population tend to vary less than other measures. So, what does that mean? You take a sample population, take a sample, take another sample from the same population. So they're took maybe different ways. Maybe this one I did systematic. I took every 50th one. Maybe this one I picked, I don't know, 5 neighborhoods and surveyed everybody or whatever it is. They usually have the same mean. They're very similar. Okay. Here, the data, the mean of the data set uses every data value, even outliers. So it uses everything. So the disadvantage is when it uses an outlier, a number way off, way low, way high, it will definitely like sway your mean. Okay. So we call that resistant. Wait, where does it say it's not resistant? Oops, hold on. I was like, resistant. It is not resistant. I saw the word resistant. I guess I didn't. I've used this note packet before. This is just a definition. I don't know why this time it was throwing me off. I mean, this is just me remaking a video I've already made like 5 times, but just trying to make it a little more new. So resistant, this is just the definition of what resistance is. So it really should be out here a little more. I'll change it probably before you even see this. But the disadvantage of the mean is that it is not resistant. So it really is affected by an outlier. So for example, if we lived in a small town like maybe KC and everybody is ranchers and they make about this much money, but you have that one person, like when Chris Ledoux lived there or something like that, that one person that makes millions, their data value is going to make the average, the mean, look really high on the income of everybody. But really, it was just one value that threw everything off. So the mean is not resistant. So if you have an outlier, don't use the mean on your project. When I ask which one you should use and you say the mean every single time, I'm going to say wrong. You can't use the mean if you have outliers. I mean, or you take your outliers out and use the mean. That's another thing like statistical thing that you can do. We don't do it a lot though. Okay, these are the notation. So this first one here means the sum. So we use this kind of funky E to mean adding up data values. So just the sum. X always represents our data, our actual data values. So if we're talking age, I'm old, like 47, almost 40. oh, I'm old. So then maybe my coworker's only 32, my other coworker's like 60. So like we could use those data values. Each one is an X. Okay. N represents the number of data values in your sample set. So I surveyed 1,000 people. However many are in your data, that is going to be the sample and the N. Big N represents the population. We ain't seeing that very much. We already know we don't have a population much. So here is the actual symbols for a mean. Please note X bar is a symbol for mean of a sample. So this is a sample. Let me just highlight this word right here. And this is in a population. So these symbols here are a big deal. So when I say X bar, it's the average, the mean of the sample values. Okay. And it's telling you to add up all your X's and divide by N. Same in the population. You're adding up all your X's, dividing by N, but this just is the symbol for I had a population's mean. You should know both of those symbols. Okay, caution. Don't use average when referring to the measure of center. We've already said that. It means all of them. So let's look at a mean for this data set right here. So let's add those all up. So if I add up each number here, I got 153.7. And there is 1, 2, 3, 4, 5 numbers. So I'm going to divide by 5. So you add up each number, divide, that's your mean. And I got, according to my notes, about 30.74. Hopefully I did it right whenever I did it. Okay. So that's going to be the mean. So the median is the next measure of center, and that's just our middle number, right? So if you have odd number of data values, it's pretty easy to find that middle number. If you have an even set of data values, so you just have 10, you have to average or you do the mean of the two middle numbers. Add them and divide by 2. So it's kind of talking about that here on all these properties, like what if they're even, what if they're odd? So you can have those in your notes. But here's the bigger deal, right? The newer part. You found the median before, I'm sure. So here we go. The median does not change by large amounts when we include just a few extreme values. So it is resistant. Oh, I keep doing the wrong one. Resistant. It is resistant. I guess I don't have to have the measure of center on there. I just want it to be resistant. So what that means is if you have an outlier, you should use the median. That's what you should do. You should use the median, not the mean, the median. So it is resistant to extreme values. The median, because it doesn't use every data value, that's why it's resistant. It's just the middle number. So let's do it of the same data here. Now, we really do need the data in order. So I purposely didn't put the data in order because I needed you to remember that part. Sometimes we just circle the middle number, but it wasn't in order, so that it really wasn't the middle. So the highest value is 55.6. And I guess I'm counting down. I don't know why. Let me just start over. I don't know why I started with the highest. Let's start with the lowest, 14.1. I don't think I've ever done that before. Oh, well. And then the next one would be the 22.4. And then 23.1 here. And then the 38.5 and the 55.6. And there's 5 data, so there's an exact middle number. So this is the median. Okay, 23.1. So on this next one, I added in an extra number so that I would have an even number, so we can see that. So again, our lowest on this one was 14.1, and then we have the 22.4, and then we have the 23.1, then we have the 24.5, and then we have the 38.5 and the 55.6. And these are irrelevant data, really, because we don't really talk about speeds anymore like this of Verizon. It's all fast. Everything's fast. Okay, so we have 6 data. So we're going to draw a line and that breaks up that middle. And what we'll do is we'll add and divide by 2 the 2 middle numbers. So we take the mean of the middle numbers. So we're going to take 23.1 and add it to 24.5, divide it by 2. I do not have the answer to that one. So 23.5 added to the 24.5. Oh, sorry, 23.1 added to the 24.5 and divide that by 2, and I get 23.8. And that's going to be your median. So even if you have even or odd, you can still do the median. Okay, almost last. Mode is our next one. So mode's important because mode is our middle of our qualitative data, right? That our words are categories. So if I have categories, the mode's the only way to find the middle. So the problem with the mode, right, is you may not have one. You may have multiple modes. So sometimes it is not useful. It just depends on your data. That's what this is going for. If you have 2 equal numbers that show up, so I think I give an example of this, like maybe your values that you have are like 2, 2, and then everything else, well, 2, 2, 3, 3, and then everything else is unique. Then you might have 2 modes, or you might be bimodal. We usually list them if there's 2. If there starts to be 2 or more, we're not listing the modes. They're kind of useless. Okay. And then if no data value, if they're all unique, we say there's no mode. So that's why the mode could be kind of useless because there might not be one, or maybe the 2 lowest values are the same and every other number is way higher. So the mode, you really have to look at the mode. But we like it for our qualitative data, right? Which is really helpful. All right, examples of the mode. So if we look at this sprint data, we're looking at here, which number repeats itself the most times is going to be that 0.3, right? It's 1, 2, 3 of those. All the other numbers are unique. So the mode would be the 0.3. Okay, look at number 2. I see 2 is twice. I see 1.5 twice. And then all the other numbers are unique. So we have 2 modes, or it's bimodal. Two and 1.5. Okay, so there's 2 of those. Last data set here. So all of these numbers, we have 70, 70, it says my internet connection is unstable. Speaking of internet, levels, but the mode on all this ones, they're all different. So it's 70, 75, 74. So there is no mode on this one. There, it's coming through a little bit better on that. Okay. Okay, last one is just not a very common one, but it's kind of our lazy middle. We call it the mid-range. It's like, all right, I'm just going to take the highest number, the lowest number. I'm going to add them and divide by 2 and call it the middle. So it's kind of a lazy way to do the middle, but it is a way to find the average or the middle of our data. And so this is our mid-range. And the mid-range is extremely sensitive. It's not resistant at all to high values and low values, because if you have a outlier, you're going to use it to find the mid-range, so because it'd be the highest or the lowest. So it's not resistant. That's a big deal. So if I have an outlier, you definitely shouldn't use the mid-range. Okay, it's super easy to do. That's why we like the mid-range. So those are the 4, with the 3 top ones being the biggest: mean, median, mode. Mid-range is a 4th one, which not bad. It's super easy, but not as reliable, just in case you have an outlier. Okay, so what would be the mid-range of this data set here, that same data set we've been looking at? Well, we just take that highest value, which was 55.6. Oops, I thought that was on my other thing. That's okay. And my lowest value of 14.1, and we would find the average of those. So add those together and divide by 2. So 14.1 plus our 55.6 and divided by 2, I got about 34.85. So let's try to decide what we should use for these three values. So what measure of center should we use for the following? So I have income of everyone in Wyoming. What's the best way to find the average, the middle, the center? Probably the median. Mode might be, but truly we'd have to look at the mode. It's a little bit harder to decide. So median or mode I'd accept, but median is probably the best because you could have some people who make nothing and some people who make a lot of money, right? And those are kind of our outliers. I mean, even one billionaire in the state and they're an outlier. So what about your grade in a course? What do you think we should use? Mean, median, or mode? Um, I go with mean. Okay. I don't know any teacher who doesn't use mean. I mean, I use categories, so I use a weighted mean, which is super common. We will do weighted means. I don't think, and all of a sudden I was like, is it in this section? Yeah, weighted means are in this section. All of a sudden, I was thinking it's in the next section, but a weighted mean is like a certain percent for each thing, or like your GPA is a weighted mean. So I give 4 points for an A, 3 points. So there's a lot of weighted means in the schools. Okay, what should I use for the average eye color? I only have one option on that one. Hopefully you thought mode. I can't use anything else. It's qualitative data. So a quantitative data set has a couple of outliers. What should I use? Well, mid-range is out, means out, right? Those are resistant. So for this one, I'm going to say median. I mean, or mode, really, for this one or this one. It just depends on what, if there is a mode and you know, if it's meaningful. You can't just go with it without looking at it. Does it really represent your center? Okay. All right. So then what if I have a frequency? So this is kind of the um, ugly notation for this idea that we're going to look at. But basically, if I have a frequency distribution, I can find the mean, median, and the mode by looking at how the distribution has gone through. So let's look at this. Oh, I forgot I wrote it in already. That's okay. So imagine that you can't see this part for a second. You have a frequency distribution, just this part right here. Okay. And that's, so you're saying 75 to this, there's 11 people and so forth. So think about if you want the mean of all of this data. So I want the mean of this data. Well, I don't know where these 11 values are. I know they're between 75 and one's at 24, but I don't really know their exact values. So what I'm going to use is this midpoint here. Okay. And the midpoint, again, let's write this in on your notes. So this would be 75 plus 124 divided by 2. So what you're doing for that is you're finding the average or the mean between the 75 and the start and the end point of each class. So plus 124 divided by 2. And I get the 99.5. And that the next group would then be, you know, these two added and averaged is this number. So midpoints are important because we're going to use them as like the average in that category. So then we're going to think of, like, I have 11 data values that are at 99.5. I'm going to use 24 data values at this number and so forth. So you could literally list these out I'm a little lazy for that. Or you can think about, what does the word times mean? It's groups of adding. So I have 11 of these. So this section right here, I'm going to take 11 times that 99.5, and it equals this. And the 24 times the 149.5, and it equals this. So we're literally timesing the number of the values times the midpoint, and that will get us basically what they all add up to in each category. So then I'm going to add up everything. So I times, find the midpoint, times, add it all up. And then the formula tells me to then divide, see, times, add it all up, divided by adding up all the frequencies. So the frequencies are the number of data values you have. So you add up all the data values. I have 50 data, and they came up to this. So the mean is going to equal 8025 divided by 50. Let me see what that is. I think it's on the next thing. Yeah, I was like, I think I wrote it out. And that's 160.5. So we can still find a mean of a frequency table. I don't remember if I show. Yeah, we're going to do it. Look at this again. I can also find the median. I can also find the mode. Okay, I can't find the mode of this one. I lied about the mode because I don't have the actual data values on this one. But I can find the median-ish, or a general idea. Well, I guess I don't think you're going to be asked that because I don't have the exact values. Nah, I'm not going to worry about it. So you could, and then I start to talk about it. So you could have, like, I have 10, like one specific number, and I have 10 of them or whatever. So then I was like, oh, you could see it this way. For now, we're just going to do the mean. Okay, let's move on. So a weighted mean is where you assign different weights to each thing, and the grade is a great way because you're in school, your weighted GPA, right? So the way that we can find a weighted mean is just kind of like we did the frequency here. It's showing your weight times the number of, it would be credits or whatever you're looking at that weight for, divided the total number of those. So grades are a great way to do a weighted mean. So look at this one. In her first semester of college, a student of the author took took 5 courses. Her final grades, along with the number of credits for each course, were given. So she got an A in a 5 credit, an A in a 4 credit, a B in a 3 credit, C in a 3 credit, and an F in a 1 credit. Okay, so GPAs at the high school are way easier to calculate because you get 1 credit. Depending on where you're at, 1 credit per year or 1 credit per semester. Kind of depends on your school. In Idaho, we did 1 credit per year. I think in Wyoming, they actually, it's shared, and at least they do half credits. So it's 1 credit for the year. Okay, so for this, what we're going to do is we're going to think about our A's, right? And our first class, we have a, what is it? A for a 3 credit class, right? And so this is going to be the grade and the credits. Okay, and the value of that, I don't know how else to say that. So the credits that we have for this first A is a 3 credit course. And what is the value for an A? It's a 4. So we have an A, it's 3 credits, and we get a value of a 4 because a 4.0 is all A's. The next class is another A, and the person has 4 credits, and the value is a 4. The next class is a B, which is 3 credits, and the value is a 3. The next class is a C, and it's a 3 credit course, and the value is a 2. And the last one's an F. It's a 1 credit course, and the value is a 0 towards your GPA. Okay, then what we're going to do is we're going to times each of these together. Okay, so times. So we'll have 12, 16, 9, 6, and 0. Okay, so we've times those together, and now we're going to add those up. Okay, what are they adding to? So 12 plus 16 plus 9 plus 6, I get 43. Okay, so that added up to 43. What do you think I'm going to divide by? Because this is what people mess up if I put it on an exam or their homework. What are you dividing by? Well, 43 represents the value for all of the credits and the value that they have. So you need to divide this by the total credits. So add up this here. So our credits were 4. So 4 times 3. And then add another 4, add another. I get 14. Does that seem right? 3 plus 3 plus 3. I don't know why that seems wrong. Yeah, no, 14. I added it in my head and I got 14. For some reason I was thinking it was wrong. So we're going to go over here and take this and add it, divide it by 14, and that's going to give me my GPA. So we're taking the total number of credits and each timesing them by the value, but then we have to divide it by the total number of credits. Because it's like the 43 represents the value towards all those credits added up. Okay, weighted means. Okay. What is the mean of the following distribution? So let's go ahead and walk through this mean. So we know that we have to find that midpoint first, because I don't really know. There's 20 values between 42 and 45, but I don't really know what they are. So I'm going to take 42, add it to 45, and divide it by 2 to get the midpoint. So this first section is going to be a 43.5, and then 46 plus 49 divided by 2 is 47.5. 50 plus 53 divided by 2 is 51.5. 54 plus 57 divided by 2 is 55.5. 58 plus 61 divided by 2 is 59.5. Then we use that midpoint kind of as our value. So then we timesed, I think this is kind of a line here. We're going to times these two together. So 20 times this, kind of this way, right? And that's going to be our next row times those. So I'm going to take 20 times 43.5. Why? Because I don't want to do 43.5 plus 43.5 plus 20 times, right? We're using 43.5 as our data value, and we have 20 of them. So we are going to just times those to get 870. And then 12 times 47.5 is going to give me 570. And then 51.5 times 7 is going to give me 360.5. And I should probably do this. I'm kind of losing my spot a little bit in my eyeballs here. There we go. That line's just not so good. My eraser's working different in the new version. I just won't pick my pen. There we go. All right, there we go. And this was here. Sorry, I just didn't like the way it looked. 360.5. All right, then 4 times 55.5 is 222, and 1 times 59.5 is 59.5. Then remember, we add those up. So add these up. So I have clear 870 plus 570 plus 360.5 plus 222 plus 59.5, and I get 2082. And then what do I divide it by? The total number of frequencies. So I have to add those frequencies up also, because that's our total number of data values. So 20 plus 12 is going to be 32 plus, plus 7 plus 5. I got 44. So 82 divided by 44, I get about 47.3. So the mean of this following distribution is 47.3. Okay, number 3. So 5 pulse rates are randomly selected from this set. The 5 pulse rates have a mean of 676.4 beats. 4 of the pulse rates are this. What's that missing value? So starting to like problem solve a little with means, we have that missing value. So we could think of this as, we know 77 plus 85 plus 63 plus 76 plus who knows, all divided by 1, 2, 3, 4, 5 has to equal 76.4. So that's kind of how you set it up. Then it's just an algebra equation from there. Then I can take that 5, right? Because I'm adding up each number, dividing it by 5 because there's 5 of them, and it better give me that value. So I take that 76.4 and I times it by 5 at first. So then now I'm going to have, well, I might add those. So then now I'm going to have 382, excuse me. So times the 5 up, right? And then from here, I'm going to add the 77 plus the 85 plus the 63 plus the 76, and I get 301 plus X down here. So I added those numbers together, times that 5 over, and now I can minus the 301 over to the 380. So minus the 301, okay? And we should get, 382, we get 81. Okay, so X equals 81. I kind of ran out of room. I'll just write it over there. So being able to find a missing value, you can do that too. You just have to think about that you're writing it as that function there. Suppose that you need to create a list of in values that have specific known means. Some of the in values can be freely selected. How many of the in values can be freely assigned before the remaining values are determined? Oh, this is straight from your homework. That's why I have it on there. So it is, when it's talking about this degrees of freedom, it's really talking about just taking in minus 1. And we do this quite a bit in statistics, is we take like 1 less than our data value because n represents our data value. So for this one, we only had 5 data. Yeah. So it would be 5 minus 1, which is going to give us 4. Um, and it's, yeah, and you're going to see degrees of freedom. So anytime you hear degrees of freedom, think in minus 1. Okay. I couldn't remember why I added that on there, but I really, just because I got a lot of questions about that. Because we don't really cover it for another couple sections, but sometimes the author throws in some things in some of those questions. It's like, oh, wait. Okay, let's look at question 4. Because the mean is very sensitive to extreme values, it is not resistant measure of center. By deleting some of the low values and the high values, the trimmed mean is more resistant. To find 10% trimmed mean for the data set, first arrange the data set in order, then delete the bottom 10% of the data values and delete the top 10% of the data values, then calculate the mean of the remaining values. Use the axial loads, it's part of the data, of the aluminum cans listed below for cans that are whatever thick. Identify the outliers and compare the mean our median mean, 10% trimmed median, and 20% trim. Would you do lots of stuff? So what I like about this question is, first of all, we haven't looked at StatCrunch yet. So if you haven't watched the whole video, I'm probably going to send you. This is where you start. So I'm going to show you this in StatCrunch for sure. But I also want you to think about, what is 10% of your data? What is 20% of your data? How would I know what that is? So I don't remember how many data values are here. So let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we know our N is equal to 20. That's our number of data values. And if I get out my calculator and I take 20 and I times it by 10%, right? Write that down for you. So 20 times 10% gives me 2. How many data values should I be deleting off the top and bottom to trim 10%? 2. 10% is 2. So we have 20 datas. I need to trim 2 off the top and bottom. But my data is not in order, and I don't want to put it in order. So I'm going to click into StatCrunch. See if I'm still logged in. I am. So here's our data here, right? You can see it. And then from here, where we haven't really looked at this yet, where we go to do anything, mean, median, mode, anything in the calculator, which you need to know how to do on StatCrunch, because you could do it on your graphing calculators as well. That's acceptable. But you really need to do it on technology, because what if you have 200 data sets? You don't want to do that mean by hand. Okay, so we're going to go to stat, and we're going to go to summary stats. So mean, median, and mode, and all of these are summary stats. Okay, so we're going to click that. And then where is your data? Is your data in a column? Is your data in a row? Is your data grouped in a binned data? That's a frequency. So if you have group binned, I will show you that too. So columns is where ours is. It was in the first column. So I'm going to pick that first column. And down here, it automatically has these stats picked. And then there's a bunch more that aren't picked. So I am going to actually unpick. Oops, I didn't mean to unpick that one. Okay, I would like mean, median, and mode, because that's, and it doesn't do mid-range for you. So you can do min and max and compute. Why would I do min and max for the mid-range? Because you add them and divide by 2. So I can just put those up there for me. So that's how easy it is to get data from StatCrunch. So this, I'm going to go ahead. Oops, let me do a split screen real fast here. It's in this one. Perfect. So that I can write some things. I know it's kind of small, but it'll be better to see the split screen. So what we can do is we can see the regular mean. Where do I want to have this? Maybe way over here. The mean of the full data set was 293.7. And does it want the median? Let's just look at the mean. I've showed you how to do the median and the mode, and mid-range, we can add the 2 numbers and divide by 2. But then let's do this 10% cut thing off. So what we're going to do is we're going to go to data, and we're going to go to sort, and we're going to say to take that first column ascending, and I want it to be in a new data set. So then you close, there it is. So now it's in order. Oh, it was already in order in there. I didn't think it was ordered. Oh, it is in order on our paper too. I think I looked across instead of down. It's in order, but it goes down. Okay, so it was already in order. That's totally fine. But that is how we put it in order again, is through the sort. And then we need to cut off the top 2 values. So I'm going to delete this one, and then go to the bottom. And I need to delete that one and delete that one. So I still have my original data, and now I have this new trimmed data. So then I'm going to go to stat, summary stats, column, and I'm going to call it out in the second sorted column now. Kind of came through a little, yeah, still stayed there, perfect. And then I really only want the mean. On your computer, you can hit Control and you can pick more than one. It's a little different. I'm on an iPad. It's way clearer on the iPad. It just comes through great. But on the computer, you have to hit control to like have more than one or change what it is. You could select them all, however you want to do that. So on the iPad, I kind of have to just slide it off and it'll come through. But there we go. So here's our new trimmed mean. So I'm going to write our 10% mean is going to be 285.8. I'm running out of room, so I'll just round it to 88. So that's our 10% trimmed mean. So 20% would then be to delete off two more values. So then I would have four values off the top and four values off the bottom. So delete that number, delete that number, delete that number, delete that number, and then this would be 20% trimmed. So stat, summary stat, column. Now it's still in that sort. And I just want the mean. So go like that and compute. So my mean of my 20% is going to be 286.5. Okay, so that is my 20% trimmed. So it's not just find your mean, median, and mode anymore. You have to decide what's resistant to your data, what's not. You have to do weighted means. You have to look at means that are missing, right, a value. You have to be able to trim off some data and analyze it better. So you can see that, you know, that from here, like our data is going lower, our mean is, because this is a mean of 293, this is 285, this is 286. So these two means are probably more accurate because they've trimmed off those end pieces. Okay, and the last data question I have was just to show you StatCrunch. And it does, let me go back to full screen. It does tell you kind of how to do StatCrunch. We just did it right here. Okay. I'm going to click into StatCrunch again. I can't think this is just straight data. Yeah, it's just a bunch of different. This is movie budgets and box office earnings. So, like the movie data, we could do a mode of that, but it's words, so we can only do a mode. Months, we can only, well, months doesn't make sense to do a mode because, well, I guess it could, depending on the data and so forth on the budget, domestic, worldwide. So, let me see if I have any data that's already in here at all. No. Okay. I wanted to show you Bend grouped data. And what I think I'll do is just open StatCrunch, a new fresh StatCrunch. This is a new function, so I don't have it on the note packet because I just found it. Oh, and then it opened this. Okay, fine. I wonder if I have one in my data set. Let me pause real fast and see and get one for us. Okay, I pulled one up. So this data set is got the intervals here of 40 to 49, 50 to 59, and so forth. So this is a frequency. It's Bend or grouped data. So I can find the mean of this on StatCrunch. So I'm going to go to Stat, I'm going to go to Summary, and I'm going to go to that grouped Bend. Okay, so the bends are the groups. Those are my intervals. My counts are my frequency. And it gives all these different statistical things that you can find. I'll just say compute of all of them. And here they are. The mean is the big one that we do, and we will do the standard deviation as well of grouped data. It also does the median and the mode, all of it. Again, it's an estimation using the mid-range, yeah, what do we call it? The class mid, do we call it the mid-range? Now I'm throwing that data out there, but taking your two classes, adding them and dividing by two, the mean of the lower and upper class. Okay, so let me show that again real quick. We go to stat, we go to columns or summary stat for all of this stuff, and we do that. Grouped bend allows you to do a frequency table. That's new. So everyone else did do it by hand before. So be happy. All right, hope this was a helpful lesson.